All right, let's talk about how to perform a two-proportion hypothesis test using RGuroo. First, we'll start with this problem where we need to choose what the null hypothesis and the alternative hypothesis is. This is very similar than the case when we have two means that we're comparing to each other. So the null hypothesis will always be assuming that the proportions are the same. So we will have a null hypothesis that looks like this. P1 equals to P2. So the proportion of the first group is the same as the proportion of the second group. And then the alternative hypothesis will either be a two-tail with a different sign or a one tail being left or right if we have some evidence, or if we want to test the hypothesis of one of the proportions being larger than the other. In this case, we have in a city known for many tech startups, 155 of 700 randomly selected college graduates with outstanding student loans currently owe more than $50,000. Then there's another city that is known for biotech firms, 184 of 700 randomly selected college graduates with outstanding student loans currently own more than $50,000. We're being asked to perform a two-proportion hypothesis test to determine whether there is a difference in the proportions of college graduates with outstanding student loans who currently owe more than $50,000 in these two cities. We're going to use a 0.10 significance level. We're going to assume that the samples are random and independent. Sample number one will be the city, the first city, the startups, the tech startups will be sample one, and the second city, which is the one with the biotech firms, will be sample number two. So then from here, we are just testing. We're going to do a two-proportion hypothesis test to determine whether there is a difference in the proportions. So it's not telling me any direction. It's not suggesting that one it's bigger than the other. So then we are going with the first one, where the alternative hypothesis is that the proportion for population number one, it's different than the proportion for population number two. Once we have determined our null hypothesis and alternative hypothesis, we need to find the test statistic and the p-value. And for that, we're going to use RGuroo. So we are going to analytics. We go to analysis, and we are going to choose the proportion inference, which is the first one. But now we are going to two populations, all right? So we have this window in here. We don't have a data set. We have information about our two samples. So then we go here. We will have to put labels in there. Let's just go down here and fill this out. So our first population is the tech starts up. So I'm gonna call it like that. The sample size, we got 700 randomly selected college graduates. The number of success is the number of students, of college students that we observed to owe more than $50,000. So this is 155. And once I do that, RGuroo calculate the proportion of success for us. Then we do population number two. So this is the biotech firms. Sample size for this one is 700. So here. And I have 184 success. Again, 184 is the number of students that we observed owning more than $50,000 in student loans in this particular city. Again, proportion is calculated for us. So let's go to the test of hypothesis. So again, we are going to change this algebraically. We always say that the difference of the proportions is either less than more than or different than 0. And the sign we use is the one that we have in the alternative hypothesis. Like just imagine algebraically, you are subtracting P2 in both sides. So in the left side, you get P1 minus P2, which is what we have right here. And then on the other side, you get P2 minus P2, which is 0. So then in here, we just need to select that not equal to sign. And then we change the significance level to 0.10. And for proportions, we always use a large sample Z. And I'm going to click the blue eye and see if it asks me to complete all of the labels. So we go here, right? So the labels are missing. So own more than 50,000. That's our success. Label for population is missing. Population label, it's college students. So label for response. It's the debt on students loan. So that's it. So here we have the tech startup 155 of 700, and then the biotech 184 out of 700. So that's fine. So we go here. The observe Z stat, this is your test statistic. So we are going to move this down to here. So let's see what it says. Round your test statistic to 2 decimal places. So if we round to 2 because of the 9, this changed to a 1. And then the p-value to 3 decimal places. So 3 decimal places will be that. 1, 2, 3, and I don't need the 1. So again, the test statistic is in here, and the p-value is this one. So sorry about that. 3 decimal places is going to be that. This is not the p-value, it's this. 2, 3 decimal places, so we should be good. And so here I'm going to submit this. And there we go. So again, let's go back here to the basics tab. All right. I'm sorry, my internet is lagging today. So again, with the information that you have in all of this paragraph, you've label your population so you know which is population number 1, which is population number 2. You input the sample size and the number of success for both populations. Remember to add labels for the response, for the success, and for the population. Then you go to the test of hypothesis and you change your alternative here and you write your significance level, and then our method is a large sample Z. All right, so then we go here. We have a p-value of 0.070 compared to an alpha of 0.1. The p-value is less than the alpha, which makes us reject the null hypothesis. And then when we reject the null hypothesis, it's because we have evidence to conclude or to go with the alternative, which is that the proportions are different. So then we say that there is sufficient evidence at the 0.10 level of significance to conclude that there is a difference in the proportions of college graduates with outstanding student loans who currently owe more than $50,000 in those 2 cities that we are using for our example. All right, so last problem. We need to find the Z and the p-value. So let's just read here. Samir is an office worker who gets frustrated by the number of paper jam in his company's printer. He wonders whether the jams are caused by the type of paper that is used. To test his theory, he prints 900 test pages using standard white paper, and then another 900 using green paper. He gets paper jams for 14 and 22 of these test pages, respectively. So 14 out of 900 for the standard white and 22 out of 900 for the green paper. it says use an appropriate hypothesis test to test whether the true proportions of paper jams are statistically significant. Assume that the samples are random and independent. White paper is going to be our first sample. The green paper is going to be the second one. We are going to identify the test statistic rounded to 2 decimal places and the p-value rounded to 3 decimal places. So I'm going to open a new window. So again, analytics, analysis, proportion, inference for 2 populations. We have a new one. So then now I'm going to start down here. So we have standard white and then green paper. Standard white paper. Sample size is 900. That's the amount of papers I'm using for each of them. Number of success for the standard white is 14. So 14 out of the white, 22 out of the green. So here are the proportions. Test of hypothesis. So it says we're going to use the hypothesis to test whether the true proportion of paper jams are different. So again, no direction. So we are going with a different than 0. And the level of significance is, it doesn't say. It doesn't say, so I'm going to leave the 0.05. I'm doing a large sample Z. And again, the success is a paper jam. Right. The response is then, it's whether the paper jams or not. So I'm just going to write an X in here. And then the population is just paper, type of paper. We go to the little I. And then from here, we're going to read what we got. So just make sure that for the standard, we have 14 out of 900. For the green paper, we have 22 out of 900. So then down here, our Z, you see this Z in here is a Z that is asking the test statistic, is 1.3468. So I'm going to get the whole thing, paste it here, and then we are going to round to 2 decimal places. And because I have a 6 after the 4, this is going to be a 5. And this is actually negative. And the p-value rounded to 2 decimal places. Again, it's 17.8, and so the 8 is going to change this 7 to an 8. So C statistic or the test statistic is negative 1.35. The p-value is 0.18. Point jumping. Z is 1.35. Oh, it's 3 decimal places. 347. 347. Negative 1.35. Oh, I changed the incorrect one. All right, yeah, I got it here. So it's 3 decimal places for the p-value and 2 decimal places for the Z. So it's negative 1.35 for the Z. I changed the test statistic to 3 and left the p-value with 2. The p-value is 0.178. So sorry about that. It's rounding. So again, test statistic is right here. P-value is right here. Round the test statistic to 2 decimal places. Round the p-value to 3 decimal places. And if you have any question, just leave a comment. Or if you have my email, then send me an email.